Hello, welcome back. 2.5, solving logarithmic equations. And whoops, I didn't write that here, but this is 2.5. Alright, so we're moving on to solving equations, okay, with logarithms. And we're going to use the LOLs, the ones we did in 2.4 here in order to solve these. There's two types of logarithmic equations. There's logarithms on both sides of the equation, which are pretty simple, and logarithms, not logarish, that's weird, logarithmics and licorice mixed together, yum. But logarithms on only one side of the equation, so both sides, one side. And I put these sort of notes in blue to remember that these things work always with natural log as well. ln always works. And once you get an answer, always check to make sure that the term next to the log is not negative, plugging answers back into the original equation. So we need to make sure that, for example, like here, log base b of m, log base b of n, the n and the m can't be negative. And so the first kind, logs on both sides of the equation, is pretty simple. If I have log base b to the m and log base b to the n, and again, they have to have the same log base b, the b has to be the same. If I have this, then m equals n. And if and only if, again, that's a biconditional, which means it can go this way or this way. So if I have this rule, log base b, we know m equals n. If I know m equals n, then I can also go back the other way and put a log on both sides, and it still equals. Okay? So, for example, in my problem here, if I have log base 13 of 5p plus 8 equals log base 13 of negative 2p. Okay? And sometimes I see you guys getting confused a little bit here. This negative 2p is together. It's like multiplied in parentheses. It's not a subtraction. Okay? And so my b in this equation is 13, right? Log 13, they have the same log here. I'm going to change color so we get out of this red here. And so since this log 13 are the same, basically they cancel out each other. And what I know is that 5p plus 8 equals negative 2p. And now I can just solve for p. So I want to get p by itself, so I'm going to subtract 5p to bring it over to this side. This gives me 8 equals negative 7p. Okay, to solve for p, divide by negative 7, and p equals negative 8/7. Okay, and so that's our value for p. However, we need to check this. Always check to make sure the term next to the log is not negative by plugging answers back in. So this term can be negative. That's okay. But when I plug it back in, these in parentheses can't be negative. Okay? And so negative 8/7 p, some of these you can just sort of guess and check. But if I plug this back in, right, negative 2 times negative 8/7, well, it doesn't really matter what that product is. I know I have two negatives that make it positive, so I know that's going to be positive. So this one's okay. This one, 5p, 5 times negative 8/7 plus 8. Okay, well, if I multiply here, I get negative 40 over 7 plus 8. Well, what's this about? Let's see. 7 goes into 40 about 5 times, right? 7 times 5 is 35. So this is going to be somewhere in the negative 5 range. And we can do that just to make sure. Yeah, so I have negative 5.7 something. Well, even when I add that plus 8, this term here is going to add to be positive, right? So since both of those work, this is a valid answer. Okay? Second are logarithms on only one side of the equation, and these are a little trickier just because there's more things that we need to remember. All right, so first thing, I need to get the log or ln by itself using equation properties and the LOLs. I should have put that in here. So we might need to use the LOLs to expand or condense. Usually it's going to be condense. Then, in order to solve logarithmic equations, and again, we're not going to have them on both sides, so we can't do like we just did. we're going to have to change the logarithmic into exponential equation, okay? And this is like what we practice in 2.3, using what we did in 2.3. Okay, so change logarithmic into exponential. Once we're in exponential, we can solve the exponential equation, equation for x. And then D is just the same thing we were just talking about here. Plug the x values in to make sure the values next to the log are not negative. Okay, so let's try some examples. I rewrote those rules up here so we can keep looking at them. Okay, so here I have an equation. Log base 4 of x minus 2 plus log base 4 of 5 equals 2. You'll notice I only have log on one side. It's only here on the left side. And I need to get the log or the ln by itself using equation properties or the LOLs, right? And so here I notice that I can combine these or I can condense them into one. And that's from the 2.4 video, condensing these into one. And so I have addition, that's LOL number 1, right? Log base 4, log base 4. So I can make this into log base 4 plus LOL 1 turns into multiplication. So this is log base 4 of x minus 2 times 5 equals 2, right? Combine this into 1. And so we can multiply these. So I have log base 4 of 5x minus 10. And this is one term together here, equals 2, right? So get the log by itself using equation properties, LOLs. All right, we have that here. So B, change the logarithmic equation into an exponential. So I need to get this out of logarithmic form. Well, I do that using what we talked about in 2.3. And so I start with my base, my 4 raised to the second power equals what's on the same level as log, and that's 5x minus 10. Okay, now I'm got rid of the log, change it into exponential. I can solve this equation by just simplifying. So 4 squared is 16 equals 5x minus 10. Okay, add 10, 26 equals 5x. Divide by 5. And so x equals 26 over 5. Okay? And so again, I need to make sure that when I plug this back in, they're going to be positive. Well, there's only one x here. 26 over 5 is about 5 something again. Right? 5.2. And so if I plug this in 5.2 minus 2, this is going to turn out to be positive, and so this one works when I plug it back in. So that's an answer. Okay? Same thing, number 3. I only have logs on one side, and so I need to use the LOLs to condense this into one log base 2. So log base 2, I'm going to start that a little bit closer so I have enough room to write. Log base 2. This, in number 2, I had a plus. Here I have a subtraction. So this is LOL number 2, right? And so this 5 goes into a division. 5 divided by negative 4x minus 4 equals 1. Okay? So again, log base 2, 5 divided by negative 4x minus 4 equals 1. And so this is getting the log by itself. I can't simplify this part anymore. So I've got to go to step number 2. Change this into an exponential equation. So I get to change this into exponential, same thing we did here. I start with my base, 2 to the first power equals 5 over negative 4x minus 4. Okay? 2 to the first is just 2. Right? So what could we do next to solve here? Well, I have a fraction. My x is in the denominator. I don't want that there. I want it in the numerator. The only way that we can do this is to get this out of the numerator. So we're going to multiply both sides by that negative 4x minus 4. And I'm going to put in parentheses so I remember that that has to stay together. Okay? Now these two terms on the right are going to cancel to become a 1, right? That's why we did that. And on my left side here, this is going to distribute. So I end up with negative 8x minus 8 equals, this canceled to be a 1, so 5 times 1 is just 5. And from here, I simplify, solve, right? Plus 8, negative 8x equals 13, divide by negative 8, and so x equals negative 13 over 8. Okay, again, I need to check to make sure that when I multiply up here, this is not going to turn out negative. Here I don't have an x term, so I plug negative 13 over 8 in here. Well, here is going to turn out to be positive, but I need to make sure that this is a bigger number than 4. Well, I know that this, when this multiplies, 13 times 4 is 52, right? So this is going to give me 52 over 8 minus 4. This multiplied to be 52 over 8. So 52 divided by 8, all right, gives me 6.5. So 6.5 minus 4, this is going to turn out to be positive, and so this answer works. Okay? Just a couple more here. Okay, what if we don't have to use the LOLs, right? Get the log or the ln by itself using just equation properties. So we're not going to use the LOLs here for number 4 because there's only one log, so we don't need to condense it into one. But I do need to get this term by itself. So I look here and I notice that there's this negative, there's this plus 9. And so to get it by itself, I'm going to use equation properties. Just subtract 9 first. This gives me negative log base 4 of x plus 1 equals negative 2, right? But I also don't want this to be negative. So I know this is a negative 1, so I'm going to divide by that, negative 1. Now I have log base 4 of x plus 1 equals negative 2 divided by negative 1 is positive 2. Okay? So that was A here. We get the log by itself, use the equation properties. B, change it into exponential equation. So now I can change it into exponential. So I have 4 squared equals x plus 1. 4 squared, 16 equals x plus 1 minus 1, and x equals 15. Okay, that's my answer. If I plug this back in, 15 plus 1, all right, that's 16, that's positive, so that one works. Okay, one more here. I have logs on both sides, so this is back to type 1, not this type 2, type 1. But I have 2 logs over here, so I need to condense this into 1. Okay, so I have log base 7, subtraction, so using the LOLs, this is LOL2. So I have log base 7 of x minus 2 over x. Okay, equals log base 7 of 47. And now using this type number 1, right, we have this same log base 7. So these go cancel. So I get x minus 2 over x equals 47. To solve, same way as we did that other fraction one, multiply by x. As I have x minus 2 equals 47x. Okay, to get x by itself, subtract x. Negative 2 equals 46x. 47x minus x, 46. Divide by 46. And x equals, well, this simplified is negative 1 over 23. Okay, this is a negative, so I've got to check, plug it back in. Oh, look at that. This is log base 7x, right? And so x here, if I plugged this back in, would be negative. So this one doesn't work. And so therefore, this is not an answer, and my answer is no solution. Just wanted to show you one of those. Okay, and again, I actually don't think I should have, but I didn't get to any of these with an ln natural log, but those would also work here as well. All right, now let's roll some dice, add these up. Enter that into your CPP, and I will see you in class.